Good afternoon, students. Please take your seat and get out your bell ringer sheets and get to work on this most missed question from the Common Assessment. I recognize that this question is a high level of difficulty. However, we will talk through it piece by piece. So make sure that you have your bell ringer sheet out and you've recorded all the necessary information. I'm going to give you about 5 minutes to work on this problem. If you're having trouble getting started, a good idea is to use the MOLA roadmap on the wall. You are starting with grams, and you do have to end up in volume, which we use liters to measure. So if you set up the equation there, going from grams to liters, that's a good place to start. Also recognizing that the question says that it has the same mass is a good place to recognize as well. Because since they all have the same mass, it doesn't really matter what the mass is. So you can assume a starting mass and then try to go from grams to liters. I'm going to go through this in about 3 minutes, but now I've given you a good starting place and a hint, so you should have no excuses for trying to work through this problem. And if you don't have a calculator, you actually don't need a calculator to solve this problem either. All right, that's about all the time we can allow for the bell ringer today. Let's go through it step by step. So, like I said in the hint I gave earlier, that since the question says that you have the same mass, you can essentially assume that the mass is anything. So I chose to assume the mass is 10 grams. So the question states that I have 10 grams of each of these gases. Now I'm going to try to go from grams to liters. So I'm going to multiply by a fraction and put grams on the bottom and moles on the top. Then I'm going to multiply by another fraction to go from moles to liters, and then I put moles on the bottom and liters on the top. If you're looking at my equation here, you can see that only one of the numbers is actually going to change, and I've represented that with an x. The only number that's actually going to change in any of these calculations with the substance is the atomic mass of that substance. So the only number that depends on the substance is the denominator of the first fraction. Since it's on the bottom of the fraction, the smaller the number is going to cause me to have the biggest final product. So on the denominator here, I want to have the smallest number possible in order to find the largest volume, which is what it states in the question. So really, all you have to do is compare the molar masses, or the atomic masses of these 5 gases. And whichever gas is the smallest mass is going to have the largest volume. And conversely, whichever mass is the largest would have the smallest volume. So mass and volume in this case have an inverse relationship. This idea that using fractions in just sort of a number sense to solve chemistry problems is a really useful skill. You can save you lots of time on multiple choice problems, and as well as improve your accuracy when you have to guess. Just to further demonstrate my point about the fractions, you can see with these two examples, the smaller the denominator, actually the larger the quotient, or the quotient, the final answer is. So in this case here, I have a 2 in the denominator and 0.5 as my answer. Here I have 10 as my denominator and 0.1 as my answer. So as the denominator got larger, the actual product the quotient got smaller. Here it was large relatively, and it had a small relatively and a large quotient. Okay, we can talk more about this in the future. This is a challenging question. Only 10% of students got it right on the common assessment in the entire district, so I know we're capable of better than that, so we can work on this when I come back tomorrow. Our agenda for today. We're going to study for the quiz, which we're going to take the last 20 minutes of class. You have physical and chemical change review, as well as review for nuclear. Your have-outs are listed here on the bottom of the slide. I'm going to give you 1 minute. Go ahead and get all of these things out. I know it's a lot, but try to get these 5 things out so that we can review them successfully. You have 1 minute starting now. All right, by this point you should have had everything out. If you can't find something or you can't find a certain set of notes, A, you need to get more organized, and B, it's really not important. All that's important is you have this blank sheet of paper and you can write down any notes that you'll need for the quiz today. A couple of expectations. I've had trouble in the past about students not behaving appropriately when I haven't been in the classroom, so I just want to make sure that we're clear on the expectations. When I ask you to work with a partner, you should do so productively and purposefully, as well as keeping your volume at a relative low minimum. The teacher has volunteered to cover this class so that I can help my basketball team out. They're doing me a tremendous favor. I really don't appreciate it when students try to take advantage of a teacher that's in an uncomfortable position. Please take advantage of this opportunity to review and respect the guidance that you're going to be provided. I've put a lot of effort into this video and putting these resources together so that you can be successful on your quiz. Please take advantage of this time to review. Just be the capable and brilliant sophomores that I frequently brag about. Just maintain the reputation that I view of you. All right, let's start with physical and chemical changes. This is the first thing we're going to review for the quiz. You can see the diagrams here. I just wanted to review these diagrams one more time so that we're all clear. So if we see similar diagrams on the quiz, you're prepared for that. Remember that if you see a physical change, the molecules themselves don't actually change. They just kind of reposition themselves. And you can see here you have two white circles, and there's still two white circles here and here. The atoms have rearranged, but they haven't really changed themselves chemically. In the example of a chemical change, you're going to see atoms or molecules split apart and form new molecules on this side. The main difference between a chemical change and a physical change is that this product here of a chemical change will have vastly different chemical properties than these chemicals on the left. So the properties change when a chemical change occurs. What I want you to do now is I want you to take a minute. I want you to review these verbs here in case you see any of these verbs on the quiz so that you're familiar with which ones are associated with a physical change and a chemical change. I'll give you 1 minute. Okay, so hopefully you've associated the types of verbs that are in the physical change and which are in the chemical change. Something like shattering is considered a physical change because it can be put back together, while something like burning or exploding is considered a chemical change verb because it can't be reversed. So you can't unburn something, you can't unexplode something. So that's why they're associated where they are. I'm actually have to stop right here and start another video because I'm running out of time. But I will be back. If the teacher could please just click on to the next video, please.